South Africa, like with Pakistan and other countries where a lot of ground mount, very harsh climate, harsh environments for PV. Are there particular technical requirements that you have to meet to make sure that the PV power plant is a successful project?
As you can tell from our logo, we want to position ourselves as the global solar farm builder. So which means we offer mechanical turnkey service to our clients. And meanwhile, we also have our core products, which is our mounting structure. And right now, I think the mounting structure people sometimes overlook because they say just some kind of metal behind the panel, that's very important. And to be honest, this is my feeling when I stepped into this business 5 years ago. I saw mounting structure and I said, easy, you just need to be neat, beautiful, that's all. And now I realize mounting structure is the foundation of your investment of solar farm, which means when we're talking about a mega project, we are talking about millions, billions US dollars. You really need to make sure the foundation is safe. And for us, for example, for our projects in Japan, we need to consider not only the wind load, snow load, we also need to consider earthquake and also the corrosion. Because Japan is an island country,
yes.
You need to take this part into consideration. And then we have to follow the most stringent local standard and international standard of the building code, okay, to make sure everything is in compliance with international standard. So for us, we think mounting structure is a critical part. All the components are critical part, but people may always look at a module or inverter.
Yeah.
But if there's something wrong with your mounting, they won't exist. Okay, so for us, we think the most important thing is to really understand the location of your project, and then you really make sure your design is in compliance with the international building code. And also you will have a very completed internal quality control system to make sure everything is under control. So far, we are lucky because we have been into this business for almost 5 years, and we also learn a lot from this, all the
from
requirements.
the collaborations, I
Correct.
guess, with the EPCs.
Yeah.
Can you give us some idea of, how you drive your system cost down?
I just give you some interesting figures. If you compare the EPC cost globally, okay, you can tell Japan right now maybe is the most expensive EPC cost country. Their cost is around 2.2 US dollar or 2.5 US dollar. And the China, the EPC cost is RMB, a yuan, something like that. Okay, 7.5 to a yuan. But if you look at the figures in Europe, people are talking about 1 euro.
That's right. Yep.
Actually, 1 euro and RMB is, it's almost equal. So why there's something behind this kind of cost compression or difference? I think is because of design, like you mentioned.
Okay.
Because,
so,
for example, we can have like a wind zone design, wind zone concept to make sure we don't sacrifice the safety factor, but we can also maintain the stability of our structure. Just to take example, 1 megawatt solar farm, just like a big forest, when the wind coming from outside into the inside, the wind speed has been reduced. But if you look at the solar farm, a lot of they look the same. They have the same span, they have the same specification. They are over-designed, and the customer is overpaying. And we are the only one right now in China. We pass wind tunnel test to verify our wind zone concept. And we are implementing this kind of design concept in all of our big-scale solar farm projects. And we can reduce not only 20% cost saving for our mounting structure, we are reducing 20% cost saving on the installation, on the foundation, civil engineering, and the total cost.
Okay, I see what you're saying. Well, there's another trend which only a few companies a few years ago would focus on, and that was using trackers because of the extra expense, the higher perceived maintenance costs. What's going on with trackers?
I think tracker is very good technology, especially when FIT is reducing. Everybody wants to improve their yield to get the same IRR.
Yeah.
But if you look at checker implication in different countries, you can see the difference. Maybe in China, checker right now is still not quite widely used. Part of reason is that in the past 3 or 4 years, some kind of substandard checker or a material checking design, they
was lacking really. There just wasn't.
Yes, so
wasn't
they will give poor performance to the project developer. So they are hesitant to take checker technology. But it doesn't mean checker is not good. Checker is good. Just depends whether you have mature technology. If you look at the utility scale solar farm in USA,
exactly.
It's very mature technology. So I think checker is good technology. Just depends whether you have mature, partner to work with. And to be honest, we are also working on our own tracking design systems, but we have this kind of difficulty because some of partner customers they try, feed-in checker before. So we need to convince them we have better design and we have better, products. But it takes time for them to convince them.
Okay. Well, thank you very much.
Okay, thank you so much.
All right.